Number 1, the function f is defined by f of x equals 8x. For what value of x does f of x equal 72? Anytime we are talking about a function with f of x equals blah, 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 what they're saying is, I'm going to give you a number x. It could be any number in the world. When you plug it in to this equation, when it says, like, what is f of 3? If f of x equals blah, 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 what is f of 3? It's saying everywhere there's an x on this side, you're going to put this number, in this example, 3, you're going to put it in. So here, when we have f of x equals 8x, let's make that a little darker, that blue, there we go, make it a little more visible. F of x equals 8x. If they were to ask what is f of 2, then we would take this little part of the function, the 8x, and everywhere there's an x, in this case there's only one of these x's, we're going to replace it with that 2. So replace that x with a 2 and we get 8 times 2, or 16. So I would say that f of 2 equals 16. So what they're asking is, f of which of these numbers equals 72? Is it f of 8? Is it f of 9? F of 64? F of 80? And there's two ways that you can look at this. You can just say, okay, just go down the list. What is f of 8? 8 times 8 is 64. That is not 72. All right, how about 9? What is f of 9? I plug it in there for x. 8 times 9 is 72. Oh, there we go. That's B. That's my answer. So the other way to look at this, which I think it's important to know this, because if you get a more complicated function, plugging in numbers may not be the best way to do it. So here when it says, when f of x equals 8x, what is x when f of x equals 72? Since f of x is 72, you can replace, go away, there we go. You can replace this f of x with 72. So let's do that. Since f of x is 72, all right, 72. And now it's just a simple matter of solving for x. When we solve an equation for x, we want to undo what's been done to x. Here, x has been multiplied by 8. The opposite of multiplication is division. So I'm going to divide by 8. What is with these tiny, tiny little lines? There we go. I'm going to divide by 8. And because this is an equation, I have to keep things equal. I have to do it to both sides. So on that right-hand side, I've undone what's been done to x. So it's just now x. And 72 divided by 8 is 9. Again, get to the same end. Our answer is B, 9. Number 2, note, figure not drawn to scale. Anytime they tell you that, and it's always kind of a good idea to assume that the figure is not going to be drawn to scale on these. They're telling you, you can't just like hold a piece of paper up or hold your finger up and kind of measure it with your, with your fingers, like holding your fingers at an angle or eyeballing it to see what the answer is. They're saying, I drew it like this, but it actually, who knows, it might be more like this in reality. It's just random lines. You can't rely on it. But we have these two lines, and we have an angle marked 1 and an angle marked 2. And it says in the figure, two lines intersect at a point. Angle 1 and angle 2 are vertical angles. The measure of angle 1 is 72 degrees. 72 degrees. What is the measure of angle 2? You may have seen in your math book vertical angles or opposite angles. It means the exact same thing. But important to know that since they are currently calling this vertical angles. And they're testing your knowledge of the theorem that says if I have vertical or opposite angles, they're going to be identical. They will be congruent. That's all it's testing. If they are opposite, you have an intersection, two lines are intersecting. Let's draw this with two different colors so it's really clear. Two lines are intersecting. If I have angles that are opposite each other across that intersection, they will be congruent. Always. These would be congruent. Those are vertical opposite angles as well. The reason for this is because, see, these two angles together make a straight line. So let's say this was, call this x, and we'll say this is 100 degrees. Since they make a straight line, They add up to 180 degrees. So 100 plus what equals 180? 80. But then if you look over at this other angle on this side, this one right here, it also is making a straight line with that 100. So it is also adding up with 100 to get 180 degrees. So what is it? It must also be 80 degrees. That's the reason why that this works. But that's all they're testing, that knowledge. You don't have to do any math with it in this occasion. Some problems in the SAT you might, but this one you don't. They're telling us angle 1 is 72 degrees. They want to know what angle 2 is. It's congruent. It is also 72 degrees. That is A. Number 3. On a street with 7 houses, 2 houses are blue. If a house from the street is selected at random, what is the probability of selecting a house that is blue? When we're talking about probability, we're talking about similar to percentages. We're talking about part out of the whole, or the total number of chances, and like the limited number of chances. And here's what I mean by that. We're looking at what are all the possibilities, and then the one possibility we're talking about, the select possibility. So here, the total, the whole, is there are 7 houses. And we want to know what are the chances of selecting a house that is blue. So what you're going to do is that limited number out of the total number. So how many houses are blue? That limited section. That limited number out of that huge, huge neighborhood of 7 houses. How many are there that are blue? There are 2. So since the total number of houses is 7, our chances, our probability of selecting a house that is blue is 2 in 7. This kind of problem, just really be careful. Read it very, very carefully. Because this one, where you're not having to do a lot of math, really, you're just having to read and answer the question, really easy to misread it. So like, let's say it just as easily could have said here, isn't blue. What's the probability of selecting a house that isn't blue? And you're like, oh, is blue 2 out of 7? And you're like, oh, they wanted isn't blue. 5 houses are not blue out of 7, 5/7. You know, that's the kind of thing they love to get people on. So just read these very carefully. But in this case, it is, as it appears to be, 2 houses are blue out of 7 houses total. 2 out of 7, or 2/7. That is my answer, B. Number 4. The graph of function f is shown. I can't get it right here. Where f of x, or y equals f of x. Okay, and we have this line there. Which of the following describes function f? Increasing linear, decreasing linear, increasing exponential, decreasing exponential. Boy, do they love these. And it's always these 4 choices. They show you a graph, or they give you an equation, and then they say, which one is it? If you're looking at a graph, the rule you're going to use is, if it's a straight line in any direction, that is linear. It is a line. Linear, line, that's what it is. It's right there in it, line. Exponential, it's going to be one of these 4. Not all at the same time, but one of those 4. That's the difference in how they look. Exponential is going to be curved, and it's going to be kind of like, it's not like a parabola. It's more wide open, and it's kind of on its side. So it's pointing towards the 4 corners, one of the 4 corners. It's kind of opening towards one of those 4 corners. That's a very general description, just how to visually recognize it. Now, the increasing, decreasing, some books have you memorize. They're like, of these 4, this one's increasing, this one's decreasing. You know, I don't like having you to memorize it. I think it's much easier just to give you this one rule, which works for both of them, both linear and exponential. We read in English from left to right. So if you're going from left to right, like we read, and you're going up, you're increasing. If it's going down, it's decreasing. That's it. So this line, as we're going from left to right, it's going up. So that is increasing. Looking at these examples of exponentials, if you get one of them instead, if it had been an exponential over here instead, First example here, as we're going from left to right, it's going up, increasing. This one, as we're going from left to right, it's going down. I didn't draw that quite right, but anyway, that is decreasing. Bottom left corner over here, from left to right, it is going down. That is decreasing. Last one, from left to right, it is going up, increasing. That's it. Same with the lines. Like if you had a line going like this, as you go from left to right, it is going down, it is decreasing. That's all there is to it. So don't memorize that, okay, if it's like this, then that means that is an increasing exponential. I'm going to memorize that phrase for that drawing. No, all you have to learn is from left to right, if you're going in that direction, is the function going up? It's increasing. Is it going down? It's decreasing, which means that our answer is it's an increasing linear. It's going up and going from left to right. It's a line. It is A. Number 5. The graph of the function f is shown where y equals f of x. What is the y-intercept of the graph? The y-intercept of any function is where it crosses the y-axis. So we just want to be careful because a lot of times we're given a graph where the origin, 0, 0, is right in the middle of the graph, but that's not the case in this one. Here, those are x and y axis, and there's the origin. It's up there. So where is my y-axis? It is this right here. It's labeled with y at the top just to make sure we're seeing it. So that's our y-axis. So I just want to look and see where is my line. This is my line right here. Where is it crossing that y-axis? And it's right there. Just be careful because they draw this, I've seen this before, where those negative signs, they almost line up with these cross lines. So it can be a little hard to see them. Just be very careful with that. That is not a 4, that is a negative 4. So it's crossing there at 0, negative 4. A y-intercept will always have 0 for its x coordinate. So here's 0, negative 4. And if we go and we look down here, sure enough, 0, negative 4, B is my answer. Y-intercept there is 0, negative 4. Number 6, x equals 8 and x plus 3y equals 26. The solution to the given system of equations is x and y. What is the value of y? A lot of times when we have a system of equations, we may want to look at it and try to figure out, is it best to graph it? Is it best to use elimination or substitution? Anytime you have something like this where one of the two coordinates of the solution, the x and y, when the ordered pair of the solution, x and y, is given, just use substitution. Honestly, I think it'll be quicker than typing this into a calculator. But if you want to, put it in a calculator, hey, I ain't going to stop you. Do what you want to do. But me, I would use substitution because we already know that x is 8, so I can substitute it in the other equation. So I'm going to plug it in there for the x. 8 plus 3y equals 26. To solve for y, I want to undo what's been done to it. So I want to get rid of this 8 first, and then I'll get rid of that 3. 8 here is being added to the 3y, so I'm going to do the opposite. I'm going to subtract it. When I subtract it from both sides, now I have just 3y on the left, and 26 minus 18 is, 26 minus 8, getting ahead of myself, is 18. And then I want to get rid of that 3. Y is being multiplied by 3. The opposite of that is dividing by 3. And I do that to both sides. I get y on the left and 18 divided by 3, or 6 on the right. And that is my answer because they're asking what is the value of y. Always go back and double check because it's possible they could have been asking what is the value of x times y. And you've just solved for y and you've entered it and then you got it wrong. That they like doing stuff like that. But in this case, they were being nice. It is just a straightforward, what is the value of y? And that is 6. Number 7. The amount of Hannah's bill for a food order was $50. Hannah gave a tip of 20% of the amount of the bill. What is the amount in dollars of the tip Hannah gave? When we're saying what is the percent of a quantity, we just need to multiply. That's it. Anytime also we're talking about percents, there's more than one way to do it. There's multiple ways. There's a lot. But at its root, The simplest sort of straightforward thing you can just remember and just do this every time when we say, what is blank percent of a number? It is that percent times that number. Always. That's the phrasing. X percent of a number. Here it is 20% of 50. We need to multiply those together. 20%, if we write that as a decimal, it is 0.2. Probably the easiest way to put that in your calculator if you want to use your calculator. And 0.2 times 50 is going to be 10. So $10 is the amount of the tip that she gave. There's other ways you can look at this. Absolutely. You can say 20%. 20% is the same as 20/100ths, which is, if we simplify that, 1/5. What is 1/5 of 50? Or 50 divided by 5? Again, that gets us to 10. So there's always different ways with percents. There's multiple ways you can look at it. They are all correct. It's whatever you want to do, whatever's most comfortable for you, whatever you know you're going to get right when you're doing this on the SAT. Number 8, which expression is equivalent to 5x to the 5th minus 6x to the 4th plus 8x cubed? Now, they are not wanting us to solve for x. It's just finding an equivalent expression. So we're going to want to factor this. That's where our mind should be going, is towards factoring. And in this particular case, the first thing we'd like to do, because we have these x to the 5th, x to the 4th, and x cubed, we have x's in all of them, is we want to think greatest common factor, because we may or may not be able to factor further than pulling out a greatest common factor. But when you have shared variables in all of these, that's the first thing you want to think of. And we can kind of look ahead and look over at our answers here, and we can see none of these answers that we were given here go further. And when I say go further, I mean like if I had pulled out a greatest common factor and then I'm left with an x squared, a quadratic, and then I was to factor that into two binomials, that kind of thing. Now, these are not the real numbers that we're using here, but that's just the idea of like the one step further when you're factoring. Looking at our answers, that is not going to be the case. It's just pulling out a greatest common factor. So if we look at this, 5x to the 5th minus 6x to the 4th plus 8x cubed, we want to look at both the constants that are connected to these variables as well as the variables themselves. So first, my constants, 5, -6, and 8. Is there anything that goes, any integer that goes into all three of those? No. No, there isn't. 5 is a prime. Its only factors are 1 and 5. 6, its factors are 1, 6, and 2 times 3. 8 is 1 times 8 and 2 times 4. So technically 1 goes into all of them, but pulling 1 out doesn't change anything, so that doesn't really help us. So there is no factor in common. So we move on to the variables. We have x to the 5th, x to the 4th, and x cubed. It's always going to be the smallest one. That's the one you can pull out. Always. So x to the power of 3, x cubed is the one. That's what we can pull out. So x cubed. When I'm taking this out, the shortcut is you subtract the exponents. That lets you know what remains. That's because we're dividing. We're saying x to the 5th, and we're dividing by x cubed, and then what remains. And the x cubed that we divided by comes out here, and what remains goes inside our parentheses. And when you divide exponents, you subtract. That's one of our exponent rules. I don't know why I erased all that, but here we are. So x to the 5th divided by x cubed, it's x to the power of 5 minus 3, or x squared. That's how that works. It's one of our exponent rules that we definitely want to know before we take the SAT. So that 5 stays there. X to the 5th, 5 minus 3 is x squared. Then we have 6x to the 4th. That -6 just stays there. 4 minus 3, subtracting those exponents, just leaves us 1. And then with the 8, we took out the x cubed, so there's no x's left. So our answer then is x cubed times 5x squared minus 6x plus 8. And sure enough, that is there. That is B. That's our answer. Number 9, the ratio of the length of line segment XY to the length of line segment ZV is 6 to 1. Okay, so I'm going to start drawing. I've got a line segment XY, and its ratio to line segment ZV is 6 to 1. So 6 to 1. So I'm going to write that. So I know that line ZV is going to be way shorter. So like if this were 12 inches, this would be 2. If this were 18 inches, that would be 3. If this were 6 inches, that would be 1. That's when it says 6 to 1. That's what it means. So, 6 times 1, 1 times 1. 6 times 2, 1 times 2. 6 times 3, 1 times 3. 6 and 1 are the two numbers we're multiplying. That's how we can get those. So we don't know the exact length of these two lines yet. We haven't been told that yet. But we know this is the proportion. This is the relationship between these two. ZV is 1/6 of XY, 6 to 1. That's another way we can write it. It means the same thing. Okay, if the length of line segment XY is 102 inches, what is the length in inches of line segment ZV? So the way we can do this, and this always works when we're talking about proportions, when we have two ratios that are equal to each other. So in this case, 6 to 1, and I'm going to write it like this because I'm going to say XY on top, and I can write it as, if I chose to write it as 1 to 6 going this direction, I could. It doesn't matter. As long as I'm comparing apples to apples. And what do I mean by that? I mean that when I say 6 to 1, this is, I'm going to erase this just for clarity, so we're very clean here. 6 to 1, this is the length of XY, its ratio, its relationship to the length of ZV. So over on this side of the proportion, now that I know the actual length of segment XY is 102, since this 6 represents in this ratio XY, then the 102 also needs to go on top because that 6 is on top. Both of the things representing XY have to be on top. Now ZV is my unknown. I don't know what that is. And since I already have an X and I have a Y and I have a Z and a V, I'm just going to put a little question mark here instead of using yet another variable. So in this case, when we have a proportion and we have an unknown, we always can solve this by cross multiplying. It's always going to work. So I can cross multiply. I get 1 times 102, or just 102, equals 6 times my unknown. I also could have written this as 6 times ZV, line segment ZV. Either way, it doesn't really matter, just as long as we know when we're working this problem what we are multiplying this by. So to solve for the length of ZV, it's being multiplied by 6, so I'm going to divide both sides by 6 to undo that. And when you divide 102 by 6, you get 17. And so that is my length of ZV, and that is A. Yeah, if I had chosen to, just as a little side note, saying, well, could I have said ZV, the length of ZV to the length of XY? Yeah, then it's just 1 to 6. And you could have done the same thing, replace this 102, this XY with 102, and again, solved, cross multiplying, you get the exact same thing, 1 times 102, 6 times ZV. Again, if apples to apples, same things on top, same things on bottom, you can get the answer. It doesn't matter if it's the other way around. Number 10, 7 times 2x minus 3 equals 63. Which equation has the same solution as the given equation? Two ways you can look at this. You could, and I think this is the longer way, you could solve for x here, and then you could solve for x for each of these and see which ones have the same answer. However, there's something I would look at before I started doing all that calculation. Look at this original. It says 7 times 2x minus 3 equals 63. And then look over at all my answers. I have 2 that have 2x minus 3 in them, and 2 that have 2x minus 21 in them. So that gets me thinking. I go, how could I get from this to 2x minus 3 or 2x minus 21 equals something? How could I get this, and is it going to match up one of these? Well, this 7 is what's making it look different, right? All of these are just 2x minus a number. And over here on the right side, we've got this rogue 7 that's messing things up. So what happens if I get rid of that 7? Am I going to get to 2x minus 3, or am I going to get to 2x minus 21? Now, if I were to distribute this 7 through here, that 7 times that negative 3 would get me to a negative 21. But the 7 times the 2x would get me to 14x. Nope, I'm not going to get there. So it's looking like the C and D, the 2x minus 21, looks like those are going to be out. But what if I divide this whole thing by 7? What if I divide both sides by 7? That will also get rid of this, as I drop my stylus, fling it at the computer. This will also get rid of the 7, which currently is being multiplied by the 2x minus 3. So if I divide it, it undoes that. And that will leave me with just a 2x minus 3 on the left, which, hey, looks an awful lot like our two remaining options. And on the right, we have 63 divided by 7, which is 9. And ding, 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 that is A. 2x minus 3 equals 9. So we don't actually have to solve for x. As long as I can manipulate this original equation into something that is identical to one of these 4, then I know that it will have the same solution because they will be the same equation at that point. So there we go. My answer is A. But again, if you really wanted to figure out what these, what the solution for x is, what x equals to, and then check all 4 of them, you could do it that way too. That is a viable way to do it. We want to do what makes the most sense to you and lets you get the right answer. Number 11, the function f defined by f of t equals 14t plus 9 gives the estimated length in inches of a vine plant t months after Tavin purchased it. I hope I'm saying that name right. Which of the following is the best interpretation of 9 in this context? For these kind of problems, when they're asking about the best interpretation, I like to get my answer first in my head before I look at their answers. There are some problems where looking at the answers is what I advise you to do first. This is not one of them, because sometimes they can be very similar as to what the answers are. And so I like to have in my head like what I'm looking for before I kind of read all their conflicting information. So here we have our starting function f of t equals random dot 14t plus 9. So when we have a function, it's saying when I plug in t, a number for t, and then I do the math, my output is going to be f of t. So if I said if t is 3, then what is f of 3? Means you're going to put 3 in wherever there's a t, you're going to do that math, and then that is going to be f of t, that value that you get. This is all about input and output. T is your input, and then what you get is f of t, your output. So there's an estimated length in inches of a vine plant t months after he purchased it. All right, so when he purchases it, t is 0 because it's 0 months after he purchased it. So what would happen if I plugged in 0 in here? I would get 14 times 0 plus 9. 14 times 0 is 0, plus 9 is 9. So at 0 months after he purchased it, I'm assuming Tavin is a boy's name. I may be wrong about that. If I'm wrong, I'm sorry because I'm saying he. I don't know. I'll just say Tavin. 0 months after Tavin purchased it, it was 9 inches because that's what this function gives us, the estimated length in inches of the vine plant. So when he purchased it, when Tavin purchased it, I'm going to keep saying Tavin, don't know he, she here. When Tavin purchased it, the plant was 9 inches long. So what is the best interpretation of 9 in this context? Well, that's the number of inches, the length of this plant when it was purchased. It was 9. And then the 14 would be how many inches it's growing each month. Because then what if it was 1 month after Tavin purchased it? So then T is 1. then it'd be 14 times 1 plus 9, or 23 inches. So it grew by 14 inches in that 1 month. So 14 is the growth each month, and 9 is the number of inches that the plant was when it was purchased. So what does 9 mean? We look at our options here. Let's see which one lines up best with what we've just determined. It says A, Tavin will keep the vine plant for 9 months. No, there's no reference to 9 having anything to do with how many months Tavin's keeping the plant. B, the vine plant is expected to grow 9 inches each month. Nope, we looked at it and said that 14 was how many inches we expect the vine plant to grow each month. C, the vine plant is expected to grow to a maximum length of 9 inches. Nope, we saw that in the very first month it grew to 23 inches. D better be right. D, the estimated length of the vine plant was 9 inches when Tavin purchased it. Yes, that is exactly what we said it meant, so we've got our answer D. 12, x plus 2 times x minus 5 times x plus 9 equals 0. What is a positive solution to the given equation? If you would like to put this into your graphing calculator to see what you get, that's valid. You can do that. I don't recommend it. I think it's taken too much time. Honestly, I think you can just look at this and you can get your answer a lot quicker. So anytime we have something that is factored, and whether that is, it could be something as simple as like x plus 1 times x minus 2, something that kind of level, and it's equal to 0. When we factor something, we always want it to be equal to 0 in order to solve for x. We know that one of these two things that are being multiplied together, if it's going to equal 0, one of them has to be 0. We don't know which one, but we solve for each one separately, and then that's how we solve for x. This principle, which you've seen in factoring, does not change if there are more binomials. I mean, we can keep adding binomials till the cows come home. It is going to be the same principle. Each one of these, we have to consider that any one of these could be equal to 0. And so we set each of them equal to 0, and then we have our answer for what x might be. Now, anytime you have one of these, especially if it's just an x plus or minus, not necessarily one with a coefficient, a constant in front of the x, if you do this enough, you start to realize, you go, okay, if it's like this, my answer is the opposite of it. What do I mean by that? So like if this is equal to 0, x minus 2 equals 0, I add 2 to both sides to solve for x. X is positive 2. It's the opposite of that. Here's the same thing, x plus 1. If x plus 1 equals 0, and I want to solve, so I need to subtract 1 from both sides, I get x equals negative 1, the opposite of positive 1. And then our other one there, x plus 9 equals 0. There, subtract 9 from both sides, x equals negative 9, the opposite of positive 9. And again, when there's no number in front of the x, that trend is going to always be the case when we're doing this. So if we factor a lot, and we've done a lot of the factoring, which you should be doing a lot of factoring if you're practicing for the SAT, I'm just saying, they always love factoring. They love, love, love to throw it in there. And so if I'm looking at these, and I've done that, I've practiced my factoring, I go, wait a minute, it's the same thing, even though it's 3 binomials instead of 2, like most factoring is, but it's going to be the same principle. One of these has to be equal to 0, and I've done a lot of factoring, so I know it's always going to be the opposite when x is just a single x. So the solution for this one will be negative 2, solution for this one will be positive 5, and the solution for this one will be negative 9. And we only have one positive solution, that's 5. So when I look at my options over here, it says what is a positive solution? 5 is the only one. That's it. I'm really quite surprised that they didn't put positive 2 or positive 9, trying to throw people off as one of those answer choices, but they didn't. That's unusual. Usually they try to be more tricky than that and try to deceive the students and throw them off the scent. But they didn't this time, and so yeah, our answer here, positive solution, is C5. Number 13, Brian saves 2/5 of the $215 he earns each week from his job. If Brian continues to save at this rate, how much money in dollars will Brian save in 9 weeks? You can do this in 2 parts, or you can do it all at once. Both will get you the same answer. So what you can do is you can say, what is 2/5? Come on, why isn't my stylus working? Come on, there we go. What is 2/5 of $215? To get that, we need to multiply 215 times 2/5. And you can do this if you just like dealing with fractions. I know not many people do, but you can just do it right here, multiplying these together, and you can cancel out before you multiply. Say, 5 goes into both 5 and 215. It goes into 5 one time, and it goes into 215 43 times. So I multiply on top 2 times 43, that is 86. On the bottom, 1 times 1, so that's just 86. So $86 is what he saves in 1 week. We need to know how much he saves in 9 weeks. So we multiply 86 times 9. 9 times 6 is 54. Put down your 4, carry your 5. 9 times 8 is 72. Plus 5 is 77. Random side note, this kind of stuff, when it's a 2-digit number times a single, I tend to do that in my head. And I do it so often like that just now when I was writing it out, I was like, wait, how do you write it out like this again? Because I always do like, okay, 9 times 80 would be 720, and then 9 times 6 is 54, and then I add those in my head, and I get 774. And I wrote 777. 774. Yeah, I don't know how other people that multiply things like that in their head do it, but that's how I do it. Years of tutoring, you have to be able to multiply things in your head quickly. It's just the way it works. So back to this problem here, we have 774, and yes, that is your answer. And when I said you could do all this all at once, like if you weren't wanting to write it out or you were wanting to just do it in your calculator, which is totally valid. You have a calculator, you want to use it, use it. You can just multiply it all at once. You can multiply 2/5, which if you want to use the decimal version of that, that is 0.4. And you can multiply that times 215 times 9 weeks. Enter all that into your calculator and you'll get the same thing again. You'll get 774 as your answer. One thing to be mindful of if you're putting it in your calculator and you put 2/5 in, just make sure that your calculator is recognizing, like if you put 2 divided by 5 times 215 times 9, make sure your calculator is recognizing this in the right way. So it's 2 divided by 5 first, then times 215 times 9, and that it's not doing 2 divided by 5 times 215 times 9. I mean, most calculators shouldn't. They should follow order of operations if you're going left to right. I just always like to mention that. Just know your calculator, know how it works so that it is giving you the right answer and you can trust that it's giving you the right answer. Because I've just seen calculators do weird things depending on how students choose to enter the numbers. And so the student trusts that the number being spit out by the calculator is the correct one. And the computer's just like, I don't know what you're telling me, but this is the number I got. It's just like not doing what you tell it to. You got to keep an eye on those calculators, man. They will mess with you. Anyway, 774, there is our answer. Number 14, a rectangle has an area of 155 square inches. The length of the rectangle is 4 inches less than 7 times the width of the rectangle. What is the width of the rectangle in inches? Okay, so I'm going to write length and width. And what are they equal to? The length of the rectangle is our cue to put the equals. The length is equal to, the length is 4 inches less than something. So 4 is being subtracted from it. It's 4 inches less than 7 times the width of the rectangle. 7 times the width. And the width is just the width. So we're going to read this one more time to make sure that we wrote down our equation correctly. Is the length of the rectangle is 4 inches less than 7 times the width. There we go. Everything is represented. Now, this rectangle, we're told, had an area of 155 square inches. So the area of a rectangle is length times width. Well, in this rectangle, our width is just W, and our length is equivalent to 7W minus 4. So to solve for this rectangle, area length times width, I'm going to multiply these two together, length times width. So W times 7W minus 4 is equal to our area, which is 155 square inches. Now I'm going to distribute this. W times 7W is 7W squared. W times negative 4 is negative 4W, and that equals 155. Now if I want to solve this, I need to have this be equal to 0, so I'm going to subtract 155 from both sides. And that gives me 7W squared minus 4W minus 155 equals 0. Now, is this something you can factor? Yes, it is. Is it something I recommend you factor? No. Not on your life would I recommend you waste time factoring this. No. This is a graph it all the way. 100% I would tell you put this in a graphing calculator. To solve this by factoring, if you're curious, you would need to multiply those together. So you'd multiply 7 times negative 155. And then with that monster of a number, which is going to be, over 1,000, you're going to have to look for factors that multiply to that number, but then add to negative 4. What is that? 7 times 155. Let's see. 700,050, 1,085, I think. Correct me if I'm wrong there. So I think it's 1,085. So you'd want numbers that multiply to negative 1,085, but add to negative 4. Hey, there's some ways you can get to that quicker than you'd think, but then you'd have to group it, and then you're pulling out greatest common factors. And just no. One of the things with the SAT is always going to be time, especially when you're at the front half of this, or even say the first 2/3 of a module. Time, man. We want to get through these as quickly as possible because in most cases, the problems get harder the further along you go. And especially the last 3 or 4 in a module can be real time sinks no matter what you do, no matter what tools you're using. So if you're in the first half, the first 2/3, we don't want to be wasting any time unnecessarily. If a thing takes time, it takes time. It's okay. Don't worry about it. But if we don't have to spend that time, let's not. This is one you don't have to spend all that time finding the factor, grouping. No. Put this puppy into the graphing calculator and you look for where it crosses the x-axis. And this one, it's only going to have one positive factor, and that is going to be 5. Because we're solving for W. W is going to be 5. Because that's what you're looking for. It's going to be 5, 0 is that coordinate where it crosses the x-axis. So 5 is our thing, and that's what they're asking for. What is the width of the rectangle in inches? W. W is 5. If they'd asked for length, we would just put it in there. 7 times 5 is 35 minus 4 is 31. And that checks out. 31 times 5 does, in fact, equal 155. So we did that correctly. But yeah, something like this, again, can you do it the other way? And a lot of times I'll say, just pick one. They're both about the same. This kid's not one of those cases. It is not faster, I don't think, at all for anyone, no matter how good you are at factoring. I don't think it's faster to factor it. So leave it be. Go with a graph instead. W is 5. Number 15. 4, 10, 18, 4, 4, 5, 6, and 5. What is the median of the data set shown? A median of a data set is the number that is physically in the middle when the data are put in order from least to greatest. So let's say I had 1, 3, 3, 6, 9, 8. Add one more here, 10. There are 1, 2, 3, 4, 5, 6, 7. 7 numbers in this data set. We want the one that is physically in the middle. That would be right here in the middle. There's 3 on its left, 3 on its right. It is the number that's right in the middle. 6 would be the median. This only works like that exactly if it is an odd number of numbers in the data set. If it had been even like this, you're like, wait a minute, that'd be right here in the middle. There is no number right there in the middle. What is it? You take the number to the left and right, the 2 numbers in the middle, and you average them together. So 3 plus 6 is 9, divided by 2 is 4.5 or 4.5. And that is our median. Now in this, they've tried to be a little bit tricky because the numbers are not in order. They have to be in order from smallest to greatest for this to work. So they're counting on someone going like 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers in this data set. So it's the 2 numbers in the middle because it's even. And there's the 2 numbers in the middle. There's 3 on each side, and there's the 2 in the middle. 4 plus 4, I average those together. 4 plus 4 is 8, divide by 2. 4 is my median. Yay! Oh no, you got it wrong. I am so sorry. We have to put them in order from smallest to greatest. Now I'm going to mark them out as I write them to make sure that I don't have any duplicates. So 4, there's another 4 there, and another 4 there. Next up we got a 5. There's another 5 there. Next in order would be 6, then 10, and then 18. But there's still 1, 2, 3, 4, 5, 6, 7, 8. So we want the 2 numbers that are in the middle. There's 3 on either side. There's the 2 in the middle. 5 plus 5 is 10, divided by 2 is 5. So the average there is 5, and that would be our median. If you had a very, very long list of numbers in the data set, it makes it a little harder to say what number is right in the middle. The trick to this is to divide the number of numbers in the data set, the number of numbers in the data set, by 2. So in this case, there's 8 numbers. You divide by 2, and that gets you 4. So you go to the 4th number and then 1 more. The 4th and the 5th number in the data set are the 2 you want to average together. If this had been an odd number, so that there were 7, you say 7 divided by 2 gives you 3.5. You go up to the next one, and that's 4. It's the 4th number in the data set. So again, if it's odd, you're going to get this 0.5 or something. Whoop. You're going to go up to the next whole number, the next integer, and that's going to be the median when you count out. It's going to be the 4th number in this case. And again, if it was even, 8 divided by 2, you get 4. You go up 1 number to that's the 5th number. You add 1, and that gets you the 5th number, and those are the 2 numbers that you average together to get the median. But again, in this case, it is B5. 16. A right circular cylinder has a volume of 432 cubic centimeters. A right circular cylinder means there's a circle on the top, there's a circle on the bottom, and it's a cylinder. And if you draw this straight line down, it makes a right angle. That is a right circular cylinder. Now there is a trick to finding the volume, or the formula for volume, of any cylinder or prism. So in any of those, cylinder and prism, we have a face on the bottom and we have a face on the top, or 2 bases, and they are identical and they are connected by straight sides that form right angles with those bases. All right, I kind of undo what I just did there, and there we go. All right, so it's always going to be the area of one of those bases times the height gives you the volume. So if this was a triangular prism, same sort of thing. It'd be the area of that base times the height. If it was a rectangular prism, area of that base times the height. And you're just going to use whatever formula for area applies in that. So again, if it was a triangular, you'd use the formula for area of a triangle to multiply by the height. Same with a rectangle. Here it's a circle, circular cylinder. So circle on top and bottom. So I'd find the area of this base and multiply it times the height. area of the base times the height. In this case, would be using the formula for area of a circle. Now they're telling us that the area of the base of the cylinder is 24 square meters. So the area here is 24. So I'm going to replace that in my formula. 24 times this giant letter H. 24 times the height. And that equals my volume, which they told us was 432 cubic centimeters. What is the height? Well, just have 24 times H, and I am going to rewrite this slightly to make it a little nicer looking. 24 times the height, 24 times H, equals 432. So I just need to undo this, undo what's been done to H. H has been multiplied by 24. I need to undo that by dividing both sides by 24 because it is an equation, so I need to do it to both sides. And when I do that, I get H is equal to 18. The height is 18. Some of these variations of this type of problem would have asked you to say find the area of the base. They might have just given you the radius in this case and require you to know that, oh, well, the area, of a circle is pi r squared, and I have the radius, and I have to do that and divide by height. They helped us out a lot by just telling us the area of the base is 24. So if we know our thing that for a cylinder, it's area of the base times height, okay, 24 times the height equals 432. There we go. They're actually being nice for once. Height is 18. That is A. 17. X squared equals negative 841. How many distinct real solutions does the given equation have? If you wanted to put this into a graphing calculator and see, where it crosses the x-axis, that would be your solution. You want to see where, if anywhere, it crosses the x-axis. You can do that. There's nothing wrong with doing that. Random ruler. There's nothing wrong with doing that if you wanted to. But you don't even have to go that far. You can just look at this and say it says x squared equals negative 841. Is there any real number that we can square to get to a negative? No. It's impossible. It's going to be a positive number times a positive number or a negative number times a negative number, because that's what a square is. It's the same number times itself. Those are the only two options when we're talking real numbers. There can be a real positive number times itself, which would be another positive number, or a negative number times itself, another negative. In this case, a positive times a positive equals a positive, and a negative times a negative also equals a positive. So there is no way that a real number squared would get us to a negative anything. It doesn't matter if negative 841. The number after is irrelevant. Just the negative is relevant. It's impossible. There are 0 real solutions to that equation. Number 18, line K is defined by y equals 7x plus 1/8. Line J is perpendicular to line K in the xy plane. What is the slope of line J? They're testing your knowledge of how the slopes of two perpendicular lines relate to each other and also slope-intercept form. So slope-intercept form is y equals mx plus b, where m and b are constants or numbers, and the x and y are the variables, that they just stay there as x and y. If you have a line that is in this format where it's y equals a bunch of stuff on the other side, then your m next to the x, the coefficient of the x, if it is there, is your slope, and your b is your y-intercept. So this is the number we're looking for in this problem because we need to know the slope of the first line before we can find the slope of the line that's perpendicular to it. So in our first equation for line K, 7 is the coefficient of x. So the slope of the first line, the slope of line K is 7. Well, now what about perpendicular lines? Perpendicular lines have negative reciprocal slopes. So if I had one line that had a slope of, let's say, 3/5, the line that's perpendicular to it would have the negative or opposite reciprocal. Reciprocal means you flip these two, top to bottom and bottom to top, becomes negative 5/3. If it is just a regular number, like say 4, and you want to know the opposite reciprocal of that, you would flip it, because this is the same as 4 over 1, 4 divided by 1. You would flip it and change the sign so it become negative 1/4. So in this case, we have our original line has a slope of 7. 7 is the same as 7 over 1. So we need to flip that and change the sign. It started positive, so we're going to be negative. Flip it, it becomes 1/7, negative 1/7. And that is B. That is the slope of line J. Number 19, we're given a table that has a number of cars and the maximum number of passengers and crew. The table shows the linear relationship between the number of cars C on a commuter train and the maximum number of passengers and crew P that the train can carry. Which equation represents the linear relationship between C and P? And if we look at all these equations, they're all very close in a lot of ways. They all have 55 as a coefficient being multiplied by something. They're all equal to either -9 or +9. The only thing that's really changing, again, is whether these are negative or positive. That's a change. And then we also have 2 of them say minus P and 2 say minus C. In that, why won't it change? There we go, to erase. And when the ones are saying minus P, they're multiplying by C. And when it's minus C, the 55 is being multiplied by P. Okay, so we could go through and plug these into each one of those equations and see which one works. I don't think you have to go that far, because C and P, so the number of cars is C and the crew is P. The maximum number of passengers and crew, I should say, is P. So either 55 is either going to be multiplied by C or P, and then the other number is subtracted, and we're going to get to either 9 or -9. So because we're getting to this number 9 or -9, when I multiply 55 times either C or P and then subtract this other number, these two results, 55 times C and P or 55 times P and C, they're going to be pretty close to each other, only 9 apart, because we're either going to get 9 or -9. Either this is going to be 9 greater than that or 9 less, and same here, or this is going to be 9 greater or 9 less. Which of those, looking at this chart up here, seems more likely? That I would multiply numbers that are in the hundreds by 55 and then just subtract 3, 5, or 10 and get 9? Not a chance, right? That's 2. That's so far apart. If I'm multiplying these, by 55, I'm going to be getting numbers in the thousands. And then I'm going to subtract 3, 5, or 10 and get back to 9? No, that's clearly unreasonable. So instead, this must be the number that's being multiplied by 55. And so that should be getting me close to these numbers over here, so that when I'm subtracting, I'll get either -9 or +9. So since I've decided that it's logical for 55 to be multiplied by C, since these numbers have got to be pretty close, only 9 apart, it's got to be either A or B. 55 times P minus C equaling -9 or +9 does not make sense. So I'm not even going to look at them. I'm not going to bother those. So now I just need to know if 55C minus P is equal to -9 or +9. And I can choose any one of these combinations up here and see what I get. So I'm going to start with the first one. I'm going to say 55 times 3. 55, come on, times 3 is 165. And I don't actually even have to do the math, because I know if I'm subtracting 174, 165 is smaller than 174, so I'm going to be getting a negative answer. -9. If I wanted to double check that in my calculator or by just subtracting, either way is fine. To confirm it, I could, and it is confirmed. 165 minus 174 is -9. So A is correct. A is my answer. If you really wanted to check to do one of these other ones, just to double check, it's going to give you the same thing every time. If you do 5 times 55 minus 284, 10 times 55 minus 559, you're going to get -9 in all those scenarios. Anyone you want. And there you go. Again, A is the answer. 20. If 4 to the power of 8c equals 3, the third root of 4 to the power of 7, what is the value of c? Okay, we have exponents being compared to roots. The rule that you need to know for this, the one they're testing you on, is that if I had, let's say, if I use, so I had 3 to the power of 2/5. How does that convert to a root? It is going to be the 5th root of 3 squared. That's how it converts. This red. The number in the bottom, the denominator, becomes the root, and the number on top, the numerator, becomes the power under the radical. Always. This is just how it works. So let's see, it was 3 to the power of 1/2. That would be the square root of 3, because 3 to the power of 1, 3, same difference. And it doesn't matter what the fraction is. It could be something really complicated, like 3 to the power of 11/37 would be the 37th root of 11. So you can go back and forth. You can convert either way. Well, here, because I have this variable in the first one, but I have solid numbers in the root, I'm going to take that root and convert it into an exponent. So third root of 4 to the power of 7, if I flip that back, my root goes on the bottom, and then the power goes on top. So the third root of 4 to the power of 7 is the same as 4 to the power of 7/3. And I've been told over here that the third root of 4 to the power of 7 is the same as 4 to the power of 8c. So I'm going to substitute that in right here and say 4 to the power of 8c. So 4 to the power of 8c is 4 to the power of 7/3. Then 8c must be equal to 7/3. And now I can solve for c. C is being multiplied by 8, so I need to do the opposite of that. I need to divide by 8, which, because we're dealing with a fraction over here on the right, dividing by a whole number is the same as multiplying by the reciprocal of that number, the fraction. So dividing by 8 is the same as multiplying by 1/8. Multiplying by the reciprocal. Same difference. Because 1/8 times 8 is just 1, so 1c is on the left. And then here I can more easily multiply those together. 7 times 1 on top is 7. 3 times 8 on the bottom is 24. And that's my answer. C is 7/24. And when you're entering that, you can enter that as 7/24 or like that, because this is a student-produced response. Or you can enter it as a decimal. You can, put that in your calculator, divide it, and enter the decimal in as your answer. Both right. 21. X minus 2 minus 4 y plus 7 equals 117. And x minus 2 plus 4 y plus 7 is 442. The solution to the given system of equations is x times x and y. What is the value of 6 times x minus 2? Okay. You don't actually have to solve for x and y in this if you don't want to. Right, and here is why. There is these kind of things. I'm just going to say anytime that you're asked not what is x or what is y, but something like this where it's, what is the value of 6 times x minus 2? And you're like, that seems oddly arbitrary. That's an unusual thing that you're asking me there. 9 times out of 10, I've only seen like one case where this didn't happen. One case where this wasn't the case. One case where this didn't happen, where 9 times out of 10 again, they give you this. It's a step in the process. Like you'll get there before you get to x and y a lot of times. So you don't even have to solve for x and y. This is like a midway point, and I'll show you what I mean by that in a second. So I have these two equations, which on their own, each one looks a little more complicated, but when you look at them side by side, you go, hey, there's some similarities here. We got the x minus 2's and the x minus 2's, and then we have this part. We have negative 4 times y plus 7, then positive 4 times y plus 7. If I were to use elimination and add these equations together, those y plus 7s are going to cancel out because I have negative 4 y plus 7s and positive 4 y plus 7s. Add everything together, those go bye-bye. And I am left with 2 x minus 2's. I got one here and one here. And then I add those 117 and 142 together, and I get 559. And so now, if you look over here, 2 times x minus 2 equals 559. Let's look awfully close. Look up here, 6 times x minus 2. How do I get from 2x minus 2's to 6x minus 2's? I need to multiply times 3. If I multiply this times 3, 2x minus 2's times 3, I will get to 6x minus 2's. You could also say, if anyone out there said, what about adding 4x minus 2's? That is a correct answer, but it does not help in this particular case. Because if I were to add 4x minus 2's to both sides, I wouldn't be getting an answer over here that's just numbers, and that's what I want because I need to know the value of 6x minus 2's. Hope that makes sense if anybody out there is like, wait a minute, why don't you just add? That's another way of doing it. Yeah, but we want something that leaves this a number, and if I multiply both sides by 3, I'll have a number on that side. And let's watch that happen. So to get 2x minus 2's, to make it become 6x minus 2's, I'm going to multiply by 3, but I need to do that to both sides. So then on the left, I will have 6x minus 2, and on the right is 559 times 3, which is 1,677, and there's my answer, 1,677. I don't have to solve for x. I just had to solve for 6 times x minus 2. Now, as always, if that didn't make sense, or you get this kind of problem and you don't remember this method, or you can't see where they're trying to direct you, how you can get to this little oddball thing without solving for x, and you need to solve for x, then solve for x. It's okay. No big. It's fine. Like if I did that here, I absolutely could do it. I could say, all right, I need to solve for x. I'm going to divide by 2 to get rid of this 2. And then I get that x minus 2 is equal to, let's see, 250, 275, 279.5. And then I would add 2 to both sides, and I would find that x is equal to 281.5. And then I could plug it into that and say, okay, 281.5 minus 2 is again 279.5. And then if I multiply that by 6, I will get back to 1,677. See, you get the answer either way. But that can save you if you have that little epiphany where you realize, wait a minute, this thing that they're asking me for, I can get there from the midpoint without having to go through these extra steps. Then it can save you, it can save you a few seconds, it can save you some time. And saving time is always a good thing on the SAT, but what's even better than saving time is getting the right answer. So if you need to solve for x to get the right answer, please do that. All right, number 22. In triangle ABC, angle B is a right angle. So I immediately want to draw this. Okay, so I have angle B is a right angle, and this is A, weird A, ABC. The length of side AB is 10 times the square root of 37. Okay, so 10 square root of 37. And the length of side BC is 24 square root of 37. What is the length of side AC? Okay, so immediately when we have a right triangle and we have lengths of sides and we're asked to be able to find the length of a missing side, we immediately want to be thinking of the Pythagorean theorem, which is that a squared plus b squared equals c squared, where a and b are the legs or the shorter sides of a right triangle, the ones that are forming that right angle, and that our c is the hypotenuse, the longest side, the one that is opposite the right angle. Right, so that's what we want to be thinking. But there's one other little consideration on this, is look over here at our answers. All of these answers are being given in the form of a square root. 14 square root of 37, 26 square root of 37, etc. So there might be a little shortcut. Ooh, went in instead of out. There might be a little shortcut to be had here in a minute. We'll see. Let's see. Okay, so I'm going to do it sort of the regular way, as it were, and then I'm going to show you a little shortcut that applies in this particular case. I'm doing it the regular way first because that will apply for any problem that is like this. So if I have my two sides that I am given, my two legs, and I am asked to find the hypotenuse, the c of the a squared plus b squared equals c squared, I'm going to take those two sides and I'm going to square them. So my one side, my a is 10 square root of 37 squared. My b is 24 times, I wrote parentheses in the wrong spot there. Come on, undo, undo. There you go. You can do it, whiteboard. 24 square root of 37 squared is equal to c squared. So when I square 10 times the square root of 37 first, since that is 10 times the square root of 37 times itself, 10 times the square root of 37, since these are both times, I can reorder things. That's called the commutative property of multiplication. Ooh, big fancy word. So when we reorder them, we would get 10 times 10, I'm putting those two together, times square root of 37 times square root of 37. So 10 times 10 is 100, and square root of 37 times square root of 37 is just 37. So all together, all of that means that 10 square root of 37 squared is 37 times 100, or 3,700. Okay, on to our next one. We have 24 square root of 37 squared. Same exact thing applies. It is 24 times the square root of 37, and when we square it, we multiply it by itself. So times 24 times square root of 37. And then we can reorder those. I'm going to just swap these two locations. So 24 times 24 times square root of 37 times square root of 37. So 24 times 24 is 576. Actually, I'm going to replace that there. 576. And then 37, square root of 37 times square root of 37 is just 37. And then 576 times 37 is, get rid of all of that, 21,312. And so if I add 3,700 to that, I get 25,012 is equal to c squared. So I want to solve for c. So to undo c being squared, I need to take the square root of it, and I need to do that to both sides. So now c is going to be equal to the square root of 25,012. Now, that can be a little bit challenging to find all the factors of 25,012, but we have a big clue, because up here in our answers, we go back up here, all of these involve, in some form, the square root of 37. So I know 37 is going to be left behind, and either, it's like 37 is going to be in there, I should say, and either it will be left behind, and I'll have a square of 14, square of 26, square of 34 under the radical that I can then pull out, or I'm going to have, it's going to be 34 times 37. Either way. So I'm going to divide 25,012 by 37. So 25,012 divided by 37, just to see what would happen when I do that. And I get 676. All right, so I'm not getting 34 times 37, so that one's out. So 676 must be the perfect square of either 14, 26, or 34. So I can take the square root of 676, boop, and I get 26. And so what I'm actually doing when I'm saying all this, just I'm going to write it out to be clear. I've discovered that the square root of 25,012 is equal to 676 times 37. And when we have square roots like this, we have like the two numbers being multiplied together under the square root, we can split them up. So you can say it's equal to the square root of 676 times the square root of 37 And we've just learned here the 676, its square root is 26. So 26 times the square root of 37, and you don't really have to have that little dot. You can just say 26 square root of 37, which is B. I mentioned a kind of shortcut that is true in this one, and this is just going to be bonus information. The way that I just showed you, a squared plus b squared is c squared. You do the things, you take the square root, and then you see which one of these it is. That is going to work on every single one of these types of problems where you're given two legs or a leg and hypotenuse, etc., of a triangle. You plug the two in, you solve for the third. That will always work. Okay, this is a little side note, kind of a little bonus way of looking at this that applies in this particular case and is just kind of showing you some interesting things, I hope, as far as how you can do this particular problem a little differently. Okay, you go back to this point where it's a squared plus b squared equals c squared. And you can look at this as you are pulling greatest common factors out. So this first one right here, 10 times square root of 37 squared, is, as we stated before, 10 times square root of 37 times square root of 37. And then we have 24 times square root of 37 times square root of 37. And just like if I had like 2x plus 2b, I could say, oh, 2 goes into both of those. I can pull it out. 2 times x plus b. I've pulled out a factor of both of those. I can do the same thing here. So here I have these two things being added together. I can say, oh, they both have square root of 37 times square root of 37 in them, which we mentioned before. Square root of 37 times square root of 37 is 37. So they both have 37 in them. So I can pull that out and say 37 times 10 times 10 plus 24 times 24 equals c squared. And move that up. Okay, 10 times 10 is 100, and 24 times 24 is 576. So 100 plus 576 is 676. So it's 37 times 676 equals c squared. You go, okay, I'm going to take the square root of both sides. You go, square root of this equals square root of that. I can split those up to be square root of 37 times square root of 676 equals c. And we're back to where we were before, where square root of 676 is 26. So 26 square root of 37. That's just a little quirk of a way you can do it for this problem. I think it's a little quicker. But honestly, I don't want you staring at a problem trying to see if there's something like this going on in it when there is a relatively straightforward, and doesn't take that awful long, normal, we'll say, quote unquote, way to do it. You know, this way, something like this will work. This is the kind of thing where if you do enough math problems and you do a lot of practice for the SAT, you might start seeing these little loopholes or alternative ways to do things. And, you know, it can save you time if you see them. But again, if you don't see them, it's no big deal. It's just another way to do it. The traditional way will serve you just fine. Number 23. F of x equals 1.84 to the power of x over 4. The function f is defined by the given equation. The equation can be written as f of x equals 1 plus p over 100 to the power of x, where p is a constant. Which of the following is closest to the value of p? Okay, first things first, I want to address this 1 plus p over 100. This is a fancy schmancy, trying to trip you up way of saying 1 point something, it's a decimal. And there's two spots, 1 point blah blah, like 1.15, 1.23, something like that. That's it. And they're wanting to know what those two numbers are. Is it 1.16, 1.21, 1.46, or 1.96? Why am I saying that? Because it's saying 1 plus one of these numbers over 100. Let's say it was 16 over 100. 16 hundredths can be rewritten as 0.16. So 1 plus 0.16 would be 1.16. So it's this fancy way, so you don't have to put like, there's two numbers after the decimal. What are those two numbers? But that's all they're asking. That 1 plus p over 100, don't let that, kind of get you in a tizzy, which I can totally see it happening. I would totally understand too, because when I first looked at it, I'm like, what are you talking about? And I'm like, oh my goodness, they are just trying to be oh so fancy and mess with you. They're just saying it's a number. It's a 1 point something, a decimal in there. What are the two numbers after the decimal? Which of these is it? Okay, so now that we've got that, we're just looking for this decimal place. Don't worry about the 1 plus p over 100. No, it just means a decimal. Okay, so the next thing we need to realize is we've got two things that are being equivalent to each other. We're saying f of x, it can be rewritten as this, so they are the same. So there is 1.84 to the power of x over 4. And then there is 1 point something, and we're trying to find out what that something is, to the power of x. And those are the same. So what I need to do is I need to rewrite this so it's to the power of x, and then I'll find out what those two decimal places, those two numbers after the decimal are. How can I do that? How can I don't know what x is. How do I convert this? X over 4 and x. The thing they want you to remember is your exponent rules. How do I get from x to x over 4? What would I multiply x by to get from x to x over 4? I would multiply it by 1/4. Is this the same as dividing by a number? Yes, it is. But trust me for this one, if you say x divided by 4 or x times 1/4, it is the same thing. Yes, in this particular case, we want to use the multiplication. Why? Because we like you. No. Why? That's an old reference. It's like even before my time. Mickey Mouse Club, if you're interested. It's like from the 50s, I think. I digress. Sorry about that. So why would we do this? Because there is an exponent rule that says it's the power to the power rule. Where let's say if I had 2 to the power of 3 to the power of 4, I can multiply those together. Power to a power, 2 to the power of 12. It is the same thing. That's what they're wanting you to make that connection. Go, wait a minute. Power to a power. I can kind of break this up. And then I would have this x on the outside. I could do this. So just like here when I said 2 to the power of 3 to the power of 4 is the same as 2 to the power of 12. The base stays the same. Just we can bust up the exponents. That's what we're going to do here. We're going to break up this exponent into to the power of 1/4 to the power of x. So, because then when we go backwards, we can multiply together. So 1.84 to the power of 1/4 to the power of x is the same as that. Because if I were to multiply these together, power to a power, I would get 1/4 x, which is the same as x divided by 4x over 4. Same thing. They're all identical. Okay, let me try to get rid of that red highlight. I got rid of my parentheses too. I knew that would happen. So now I know 1.84 to the power of 1/4 to the power of x equals 1 point something or other to the power of x. All I need to do is type in 1.84 to the power of 1/4 into my calculator, and I will get 1.16467. And here it's saying which of the following is closest to the value of p. Remember, because we're going to be rounding it to those two places. And if I rounded it to those two places, it would be 1.16. That is the closest to the value of p of those. 16, 21, 46, 96. 16 is the closest, and that is A. Because 1.16 is the same as approximately 1.16 is the same as 1.84 to the power of 1/4, which then would be the same, as that to the power of x. Yeah, they love trying to make these extra complicated by throwing in those little wrinkles. Sorry about that. Sorry you guys have to deal with that. Number 24, the function f is defined by f of x equals a times the square root of x plus b, where a and b are constants. In the xy plane, the graph of y equals f of x passes through the point negative 24, 0, and f of 24 is less than 0. Which of the following must be true? Okay, so we have f of x equals a times the square root of x plus b. A and b are numbers. They are constants. All right, we are told, said, when we graph this, where y is f of x, we, putting y in for f of x, we can graph this. It passes through the point negative 24, 0. Well, let's plug in negative 24 and 0 into this equation and see what we would get, or what we might be able to deduce about this. All right, so if x is negative 24 and times a, and we get that y is equal to 0. All right, so what can we learn from this? What can we kind of start to figure out about a or b? Or what we might say could be true about a or b. We might not be in the must be true yet, but could be true about a or b. Well, first, it's equal to 0, not undefined, not like that. So I know that this number under here is either going to be 0 or it's going to be positive for this to have a solution and it not be undefined, because we can't have a negative under the radical. But also I have this a out here, so I'm multiplying a times the square root of negative 24 plus b, and I get 0. So to have two things being multiplied together that are getting 0, one of them must be 0. So it's two possibilities. So either a equals 0, or to make this under here 0, b would have to be a positive 24, because negative 24 plus positive 24 would be 0. So either way, either a is 0 or b is 24. Okay, now what is our next fact that we are given? We are given that f of 24 is less than 0. All right, so let's plug in f of 24 for x. And it says that it is less than 0, so it's a negative number of some sort. It's a negative number over here. Now let's test out our two possibilities. We know one of these is true. Either a is 0 or b is 24. Okay? What happens if I plug in 0 for a? Doesn't matter what b would be, because it would be multiplied by 0 and I would get 0 again. Not less than 0, not a negative number, just 0. That's not happening, so a is not 0. So this must be true. B is 24. Well, what happens when I plug in 24 for b? I'm getting a times the square root of 48. The square root of 48 is not an integer, but it is a positive number. And it's being multiplied by a, and then the result is a negative number. So what do I know from this? I know that a has to be negative. A must be a negative number. Okay, so now I have these two facts I've learned. I learned that b is 24 and a is less than 0. And let's look at their options of which of the following must be true. And let's see if we can answer this without having to do anything additional. First, f of 0 equals 24. No, I don't think we know that. That must be true. So we don't know the value of a. We know that it's less than 0. It's negative. No, that f of 0 must be negative 24. No, we don't know that either. We don't know. If we plug in 0 for x, in this equation up here, because we've discovered, discovered that b is 24, so like f of 0, so I plug in 0 for x, and I still wrote x again. If I plug in 0 for x, that I must be 24, it must be negative 24. No, because I don't know what a is. I can't answer if either of those must be true. They could be true, but I don't know that. I don't. All right, both of those are out. A is greater than b. Nope, because we know absolutely B is 24 and A is a negative number. So A is not greater than B, which brings us finally to D. A is less than B. There is our answer. It is less than B because B is a positive 24, and while we don't know what A is, we know it's negative. So D must be true. 25. In the xy plane, a circle has center C with coordinates HK. Okay, so somewhere in the xy plane, this is C and it's HK. Points A and B lie on the circle. Point A has coordinates h plus 1, k plus square root of 102, and ACB is a right angle. What is the length of line A, segment AB? Okay. So h plus 1. So there's this circle. Oh, that's an awful circle, ain't it? Whatever. Right? So h plus 1, k plus square root of 102. So it's somewhere over here because it's x, the x value, one more. So this is not drawn to scale. I'm not using the grid in the background. I'm just saying went over 1. Okay, and this has a coordinate h plus 1, k plus square root of 102. Okay. And this is point A, and ACB is a right angle. So AC, let me rewrite this HK over here. Okay, ACB is a right angle. What is the length of AB? This is what we're trying to find. The hypotenuse of this right triangle that we've created. Now I know this is a circle, and both A and B are lying on the circle. So AC and CB are both radii of the circle, so they are the same. The circle has a radius the same all the way around, right? So I know AC and AB are the same. This is an isosceles right triangle. So the thing we know about isosceles right triangles is they are 45, 45, 90 right triangles. And while we absolutely can use Pythagorean theorem in these cases, there's also this fun little shortcut that we probably learned in geometry, which says if this side is A and this side is A, this side is A times the square root of 2. We'll come back to this in a minute. All right, going back to over here, our triangle inside this circle. What I need to do is I need to figure out this distance. How do I find out the distance? We're going to use distance formula. So distance formula is if you have 2 points, let's say we have x1 and y1, and we have another point x2, y2, there is a formula that is itself derived from doing this kind of thing of making a right triangle and using Pythagorean theorem, but it is x1 minus x2 squared plus y1 minus y2 squared, and it's the square root of all that. It is just doing a squared plus b squared equals c squared, and then they're deriving this formula from it. I'm not going to go into how it's derived. I have a video down below if you want to see more about distance formula and how it comes up, but that is our formula. I think sometimes they rewrite it the other way and say x2 minus x1 and then y2 minus y1. I've seen it both ways. It doesn't matter. Just make sure that whichever ordered pair you pick, like if you pick this one to be your first one, make sure it is taking up the first positions, and then if that's your second pair, it's taking up the second positions, that you're just consistent in that way. That's all you have to do. Okay, so we are going to use this formula. We're going to, it's going to be big over here. All right, so first I'm going to take this and I'm going to subtract the coordinates for point C. I'm going to take the coordinates for point A and subtract the coordinates for point C. So h plus 1 minus h squared, the x coordinate for A minus the x coordinate for C squared, plus k plus square root of 102, that's our y coordinate for A, minus the y coordinate for c, which is k squared. Now, it looks messy at first, but hey, those h and k's, they're going to disappear. I'm going to be left with just numbers, which is why we're able to have just numbers in our answers. So first, h minus h, because we can view this as plus a negative in both cases. So we can do this. We can say h plus a negative h. Those cancel out, leaving just 1, and 1 squared. And then I have k and a negative k cancel out, so I just have square root of 102 squared. And all of this is square rooted. So I have the square root of 1, square root of 1 squared plus square root of 102 squared. So first that square root, that 1 squared is just 1. The square root of 102 squared is 102. So that is the square root of 1 plus 102, or 103. So now I know my radius is the square root of 103. And I think if I recall correctly, for the answer key for this one, the College Board actually went at this point through another Pythagorean theorem, I think, to find the hypotenuse. I'm like, why would you do that when we have our little shortcut? If you need to do that, that's fine. But if you can remember this shortcut, or if you reference it, because it's one of the included references for the math section, dude, just use that. Save yourself the pain. So I know now square root of 103 is my a. So to find the hypotenuse, I just multiply that by the square root of 2. So square root of 103 times the square root of 2. You just put those both under the same radical. The square root of 103 times 2. So the square root of 206. And that's a. That's it. Square root of 206 is your answer. Yeah, that one's a bit messy. But distance formula, which does not often show up on the SAT, I was kind of surprised to see it. But yeah, they do like to throw those things in on occasion. Number 26, the scatter plot shows the relationship between two variables x and y for data set E. A line of best fit is shown. Data set F is created by multiplying the y-coordinate of each data point from data set E by 3.9. Which of the following could be an equation of a line of best fit for data set F? And we've got two sets of answers. When I say two sets, each of these sets of answers shares something in common. So I have one that has the y-intercept 46.8, one that has a y-intercept of 12. And then I have a set here. You could look at this as a set, has a slope of 5.9, and this has a slope of 1.5. Now, why am I saying this with slopes and y-intercepts? It's because they are following the format y equals mx plus b, where I have a number multiplied by x, and I have a number standing alone. And the number multiplied by x is my slope, and the number that's standing alone is my y-intercept. So even though they reverse that and they put the b's first, still the number standing alone. So those are my two, my y-intercept possibilities, 46.8 and 12. And here are my two slope possibilities, 5.9 and 1.5. So let's look for slope first. Let's say, which of these seems more likely, 46.8 or 12 for this new line? And let's look again at what they said, what we know about this line. I'm going to really just kind of zoom into just our graph here. There we go. Okay, so this is our data set E. Then we have this new line of best fit for data set F. And data set F multiplies just the y-coordinate, not the x-coordinate too, just the y-coordinate for each point by 3.9. All right, so our current y-intercept looks closer to 12. Yeah. I have down there the 12. Like, yeah, it looks closer to 12. But that's not going to be the new y-coordinate. So for this y-intercept currently, it looks like it's 0, 12. But I know our new data set F, they multiply just the y-coordinate by 3.9. So I need to do that. I need to multiply 12 by 3.9, and dun, 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 what do I get? I get 46.8. Okay, so now I know that these two are out. That y-intercept cannot be 12. It must be 46.8. Okay, so now let's move on to slope. All right, so let's find 2 points here, figure out what their new values will be, and then we'll find the slope. And that will help us, even if it's not exact, because this line of best fit isn't really exact as to the little points it's going through. It's kind of hard to tell. But this is so different, 5.9 versus 1.5. We'll be able to tell which of those is closer because it's saying which could be an equation. All right, so I'm going to start with that same point. That was 0, 12. And then when we multiplied this by 3.9, we got 0 and 46.8. And there's another point here. If I'm looking around, like even these aren't exact, but that one's pretty close to being on the line. Close enough for our work. So it's 12 and 30. Which means my new point will be 12 and 117. Okay, so how to find the slope from these 2 points? It is change in y over change in x. So in change in y, I went from 46.8 up to 117. And I can choose to subtract. I can go this way or I can go this way. Either way is fine. I'm going to go this way. So it's 117 minus 46.8. And on the bottom, it is 12 minus 0. And this is a moment where, yeah, you want to pull out your calculator. I wouldn't blame you. So 117 minus 46.8 is 70.2. And when we divide that by 12, we get 5.85. And lo and behold, that is very, very close to 5.9. Certainly not 1.5. So A, that could be an equation for this new line of best fit. Again, we just took that y-intercept multiplied by 3.9 and then took this line, changed 2 points, and then did the slope off of those 2 lines. Another one of those problems you're unlikely to see in your math book, but it kind of combines stuff you learned in other areas. Number 27. 48x minus 64y equals 48y plus 24, and r times y equals 1/8 minus 12x. In the given system of equations, r is a constant. If the system has no solution, what is the value of r? If we're speaking in graphical terms, when we have a system of equations, it can be 2 lines, it can be, a parabola and a line, any of those combinations, there's tons of them. And we're always looking for the place where these, the graphs of these equations intersect. And there are ways to solve systems of equations, on paper. But if we're visualizing them, that's what we're thinking of is where do they cross in the xy plane? Now, if we look at these 2 equations, they both just involve x's and y's. There's no x squared, x cubed, square root of x, random ruler. There's none of those things going on. So these are just lines. Each of these is a line. Now, if I have in my system of equations 2 lines, there's 3 options for what can happen. They may intersect, in which case they have one solution. They may overlap, be right on top of each other, in which case there are infinite solutions. Or they may be parallel to each other. And in that case, there are no solutions. So for both this one and this one, the way you can tell that it's one of these 2 is that they will have the same slope. If it's this one over here, it has the same slope and also the same y-intercept. And over here, it will have the same slope but different y-intercepts. So since we're talking about no solution, we know we are dealing with this one over here. So if we look at them graphically, we want to see these parallel lines. If we're looking at them on paper, we want to see the same slope, different y-intercept. Now, can we solve this through graphing? We have this unknown constant. If there is a known constant, if this was a number, then yes, we could solve this graphically. We could see what's going on. But that's the kind of problem where you're saying, where do these lines intersect? What is their solution? Graphing is often an option. This one, not so much, because we have this unknown, this r. And trust me, you don't want to just graph these and just start plugging numbers in for r. don't do that. In this particular one, you're going to be sitting here a while, I suspect, before you find the right answer. Now, there are two different ways we can look at this problem. A lot of times, when we have these sort of funky puzzle problem, let's use a bunch of different things you've learned over the years in one, which is usually in these higher numbers when we get up to the 20, 20 to 27, we get more unusual problems that you may not have seen similar examples in your math book before. That just happens. This particular one, there's two ways you can solve it. I'm going to show you the more, let's say, traditional way first, and then I'll show you a little shortcut of sorts that I saw that worked for this particular problem. Okay, as I mentioned, first, the traditional way first. As I mentioned just a few seconds ago, we're looking for them to have the same slope. Now, the easiest way to kind of compare these two and get them to have the same slope is if we put them both into y equals mx plus b format. When we do that, when we have y by itself and just a single y and everything else on the right, the m, the coefficient that's by the x, will be our slope, and the b there will be our y-intercept. That's the number that's all by itself, all by its little lonesome. So let's put both of these into y equals, and then everything else on the right, format, and we'll have our slopes. So our first one, our top equation, 48x minus 64y equals 48y plus 24. We want y by itself, everything on the right. So first, and it really doesn't matter where you start, just as long as you get to that point. I'm going to move that positive 48x by subtracting 48x from both sides. That gets rid of it on the left. Then I have negative 64y equals negative 48x plus 48y plus 24. And then next step, I'm going to get this y, the set of y's, these 48 y's, I'm going to move them over to the left. Since we have here adding 48y, I'm going to do the opposite. I'm going to subtract 48y, and that will effectively move it to the left and get rid of it on the right. So on the left, negative 64y plus a negative 48y is negative 112y. And then on the right, I have negative 48x plus 24. Now I'm going to divide everything by this negative 112. So now I have just y by itself, and it's equal to, and those negatives cancel out, and I will simplify this in a second, 48 112ths x plus, actually let's change that to minus because it's, instead of plus a negative, let's just make it cleaner. So minus 24 over 112. I'm not going to worry about simplifying the 24 over 112 because it doesn't matter for our problem, and I'm not going to waste my time on that on the SAT. I am going to see about simplifying this one because I think that's going to help me in a minute. I like having more simple fractions. So let's see if we can do that quickly. Now, even if you don't see the greatest common factor that's in here, that's fine. What you can do is you can go, they're both even. And you can just start with that and just start working away at it with them being both even. You might look at it and go, I know 4 goes into 100 and then 4 goes into 12, so 4 must go into 112. And I know 4 goes into 48, so I'll start with that. I'll take 4 out. It really doesn't matter where you start as long as you're like whittling it down. You also can use factor trees. Videos on that will be below if you want to find out how to use factor trees to find greatest common factors. Totally viable as well. All right, but I'm going to just divide by 4. When I do that, 48 divided by 4 is 12. And here, 112, divided by 4 is 28. Like, they're still both even, and also 4 goes into both of those. Okay, so I can go a little bit further. 4 goes into 12 3 times, and it goes into 28 7 times. I think I've got my simplest form, 3/7. So this is the same as y equals 3/7 x minus 24 over 112. All right, so now I know that my slope for that first line is 3/7 x. So I'm going to write that up here. My slope for that first line is 3/7. Okay, so now we're going to need the space, so this is all got to go. We're going to move on to our second equation. And that is r times y equals 1/8 minus 12x. And I'm going to reorder those so it looks more like my y equals mx plus b. ry equals a negative 12x plus 1/8. Now to get y by itself, it's currently being multiplied by r, our unknown constant. So I'm going to divide everything by r. And this one right here, when you divide a fraction by something like 1/8 divided by r, dividing by r is the same as multiplying by 1 over r. Just like, dividing by 2 is the same as multiplying by 1/2. Same principle at work. So 1/8 times 1 over r is how you would do that. Okay, so back to our equation here. R times y, and then I divide it by r. So on the left, I just have y. My next one, I have negative 12 over r x plus, as I said, it's 1 over 8 times 1r. So 1 over 8r. But again, also, this doesn't matter. Y-intercept doesn't matter. I don't care about it. All I care about is my slope. And I know now that the slope of my second line, its slope is negative 12 over r. Now, I need these slopes to be the same for this system of equations to have no solution. They need to be the same. They need to be equal. So I'm going to set them equal to each other and then figure out what I could put in for r to make this a true statement. So 3 over 7 equals negative 12 times r. And there's two ways that you can do this. I'm going to show them to you next to each other. Okay, one thing you can do, and it always works, is you can cross multiply. So I get 3 times r is 3r, and 7 times negative 12 is negative 84. Then since it's 3 times r, I want to undo that, so I will divide by 3 on both sides, and I get that r is equal to negative 28. That always works no matter what numbers you have in this proportion. Now my second way over here is a shortcut of sorts. It works if you can multiply, say, one of these numbers to get to the other numerator, or if I could multiply a denominator to get to the other denominator. That's not always possible. It could have been something like 3/7 equals 5 over r. There's no way to multiply 3 by an integer to get to 5. 5 is not a multiple of 3. This particular case, however, we can use that shortcut and say 3 times what equals negative 12? Negative 4. So then I would multiply the same thing on the bottom. 7 times negative 4 would equal r. So r is 7 times negative 4, or negative 28. That's another way you can do it in this particular case, but like I said, sometimes the numerator is not a multiple of the other numerator, so you can't do that. Oh, times negative 4 times negative 4. This way will always work, regardless of whether that multiple thing is true or not. So r is negative 28. That is my answer, and I'm going to write it over here. And now I'm going to show you the other way that you could have found this out, which works in this particular problem. And I want to always differentiate those two methods, because there are ways that will work for a particular problem because of the parameters of that problem. But the way I just showed you, where we find the slope of each of these by putting them into y equals mx plus b and then setting those slopes equal to each other, would always work regardless of any of the quirks of how these equations relate to each other. And there is a quirk here that you can exploit in this particular instance. And if it's one of those things where if you see these exploits, you see these little quirks, these little shortcuts, it can save you time. But if you don't see them, it's okay. You still have the way I showed you before will absolutely work. So here is the quirk that sometimes happens It's if when you're working this, you realize that the equations are starting to look like each other. And if you can get them to look like each other, if there's a way you can manipulate things so that they look like each other, you'll have your shortcut. Let me show you what I mean. 48x minus 64y equals 48y plus 24. If I start moving things over like I was doing before, I'm starting out that same way because that's my method. I'm like, I know, I'll put them both into y equals mx plus b. I'll set the slopes up, equal to each other. Okay, so let's start that process. It's going to start out exactly the same. Where I moved the x over to the right by subtracting 48x from both sides. It's like, okay, so now I've got negative 64y equals, and I'm just going to write, okay, so 48y plus 24, and then I subtracted that 48x, okay. And then I want to get the y's over to the left, so I'm going to subtract that 48y, so it'll cancel on the right. I have to do that to both sides. Then, like before, I get negative 112y equals, the y's cancel out, 24 minus 48x. And here's when I look at it and go, this is looking kind of similar to that. Is there something I could do where I could get those x's to be exactly the same? Is there anything I could do to this whole equation to get the x's in these two equations to be the same? Because if I did that, if I could get the x's to be the same, because that's where the slope is, then all I would have to do is look at what coefficient is here by y, and it would be the r, because they would have to match. They'd have to. The coefficients of the x and the coefficients of the y. If the coefficients of the x match, then the coefficients of the y would need to match too for these to be parallel. Because when you go that next step further and you start solving for the slope, I would be dividing by this number. So it would be this coefficient divided by this number, and over here it's going to be this coefficient divided by this number, and they would have to be the same. So I'd have to be dividing by the same thing if the coefficients of the x were the same. Okay, this may be a little tricky to understand. I get it. I hope I'm explaining it well. But yeah, like I said, previous way, always going to work. Okay, so let's look at this. What can I do to get from negative 48 to negative 12? And we always want to think about like multiplying and dividing because that's something that will affect everything. Whereas if I add or subtract, that only affects the x. We want to affect everything. So if I divide negative 48 by 4, I will get to negative 12. So let's do that. Let's divide everything over here by 4 because then it all stays even. Everything's good. What do I get on the left? Negative 112 divided by 4 is negative 28y equals 6 minus 12x. And there we go. They are set up to match. The 6 and the 1/8 don't match, and I wouldn't expect them to, because this number that's by itself is what's going to become, or what represents the y-intercept once I get it into y equals mx plus b form. So they should be different because they can't have the same y-intercept. But now I've got my negative 12x, negative 12x. I've got a coefficient by a y. That one has a coefficient by a y. They would have to match so that in the next step, when I divide by that coefficient, I get the same slope for both of them. Because I'm going to divide, down here on the bottom, I'm going to divide everything by negative 28 to get y equals. So it's going to be negative 12 divided by negative 28, and that's going to be my slope. And up here, on the left up here, same thing. To get the slope, I've got r times y, so I'm going to divide everything by r. So it'll be negative 12 divided by r, and they have to match. So that r, it must be this coefficient here. It must be negative 28. And so if you have that sort of epiphany as you're working through this, when you get to this point, it does save you time. It does save you steps, because instead of dividing by negative 112, simplifying that fraction, then converting this one, then setting those slopes equal to each other, solving for r, all you do is one more step of dividing everything by 4, and then your answer's there, ta-da, right in front of you. those kind of little shortcuts and things, they get easier to see the more you practice, the more you do with the SAT problems, especially these end of the road, end of the section problems that are a little more tricky, that are a little more multi-step and puzzles. Where they're like, pull together everything you have learned into one problem and show us what you know. It's that kind of thing. Whereas up to this point in the sections and the modules, it tends to be more like, here are problems you've seen in school. And then you get to these at the end, and it's like, hey, have fun. The more of these you practice, the more of these you do, the more likely you are to see these kind of, these little tricks that can cut time out and give you a little more time to work on other problems, to check your work, things like that. But said it before, and I'm going to say it again, it doesn't mean you're going to get it wrong. If you don't see their little shortcuts, you still have the more traditional methods to rely on. They will get you the answer. And you've reached the end. Congratulations. Hey guys, head over to my new site, mathwithalyssa.com, to get your free 10-video course of SAT tips and tricks. It covers things like how to make a study plan that's perfect for you, how to pace yourself during the test to get maximum points, and so much more. I'm super excited to get this out to you guys, and a lot more SAT prep help is coming for you in the weeks ahead. Again, that is mathwithalyssa.com. And if you liked the video you just watched, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.